It's always great to have you guys, and I will now step aside, and it's entirely up to you. So, floor is yours, guys.
Fantastic. I appreciate it. Thank you, Graham. So hello, everyone. We're always happy to be here with IWPC members. And we'd like to, with this audience, we'd like to go a little bit more into the weeds because we know there's a lot of, it's mostly comprised of network engineers with deep hands-on expertise. And today we're going to go sort of deep into graph as a technology. So I think with the rise of Gen AI and Agentic AI and the desire for autonomous networking, there's this growing understanding that there's a need for context. And there's an association with context in graphs. But graphs are often just spoken about from the perspective of data science and analytics, and they're generally not described in ops terms or systems engineering terms. And that's what we're going to try and cross that divide, how graphs relate to net ops and support this new generation of AI. So we're calling this context as a service for telco-grade AI. Network automation shouldn't be a pain in the graph, and we truly believe that. And hopefully you'll find this compelling. Today's presentation is going to be broken up in two parts. We're going to sort of give you this sort of background first, like the current challenges, the need for context, the role of sort of a comparative graph technologies. That's going to be the first half. And then we're going to segue to a demo. So we're gonna make some assertions about graph technologies, and then we're going to demonstrate a specific use case using Agentic AI, and it's going to happen to be a demonstration over a Snowflake data warehouse, and we're going to show how we can connect a warehouse to a land graph agent and leverage NLP, do both chatbot functions, but also do orchestration functions with that agent. So it really demonstrating how context supports autonomous networking and intent-based orchestration, et cetera. So some quick background on us, and if somebody hasn't seen one of our presentations on IWPC before, EnterpriseWeb was actually the first to demonstrate telco-grade generative AI with Microsoft back in May 2023. If you remember at MWC 23, no one was talking about generative AI. It sort of broke on the scene that spring after MWC, but at February 23 MWC, we were actually meeting with Microsoft leadership, and they wanted us to deliver a telco-grade demonstration. And all the way back in May 2023, we demonstrated how you can talk to the network to design, deploy, and manage complex network services. Then we were last year, we were the first to demonstrate CPU first Gen AI with Dell, Intel, and Red Hat. That was showing how we could run on CPU, optimizing AI and network workloads at the edge. And we fully benchmarked that in the Intel labs. That was last year. And this year, we're doing this demonstration with Agentic on Snowflake. So we have a strong history in telco, but also pioneers in advanced AI-based automation. We also happen to have 23 awarded patents on context-aware information systems. So this is our wheelhouse. If you want to check out my blogs, you can follow me on Medium. It's just, you can see the link there. Our videos are all up on YouTube, and there's tons of demos there. And you can please connect with me on LinkedIn. So as I said, I'm going to start off with some assertions. It's a bold statement, but I think many of you at this point realize it's true. Gen AI and Agentic AI are not telco grade. The evidence is all around us. Literally, an agent recently deleted an entire company database. You've had agents hacking their own guardrails. You had one of the co-founders of OpenAI calling Agentic AI slop. All these are from recent articles. The links for the articles are right there. And you had a Nobel Prize winning economist saying the real threat of this current generation of AI is so automation. For the billions of dollars that are being spent, the fear is that we might not move so far, right? And so how do we avoid this problem, right? Statistical pattern matching on its own is not good enough for reliable, available networks. I'm not trying to say Gen AI and Agentic AI are bad. It's just that they have weaknesses and issues that need to be mitigated so that you can leverage them safely within your NetOps environments. So here's some recent academic papers which also support my conclusion here, my assertion. I'm not going to go through all of them, but this recent one in the upper right corner here, it's from IBM Research. It's from November, and it's called Nestful. You can look this up. Again, the link is there when they show the deck. It's built into the deck, and they literally show how the more steps and the more complex the tasks, the lower the success rate of agentic LLMs on supporting complex multi-step reasoning. Their score was 35%. Now consider, would you hire a developer that whose work was only good 35% of the time? Is 35% good enough to run available, reliable network? Again, it's not that Gen AI and Agentic AI don't have the use cases and don't even have early successes. But now we're talking about NetOps, right? And I know all of you are very sensitive to what goes into production on the network side. So what's the problem here? Because I think there's a lot of hype, and we got to separate the wheat from the chaff. I mean, LLMs are routinely called stochastic parrots, and I'm going to call agentic AI tin men, and they're essentially despite the hype, and despite the words that are used around them, the terms that are used around them. People talk about reasoning, and they talk about context, and they talk about automation. They talk about all these things, but they're not really at the same level. Gen AI that you guys are used to when you're doing automation inside your networks. So Gen AI and Agentic AI emulate, but they cannot replicate knowledge engineering and programming languages on their own. Right? They're just not good enough. Statistical probabilistic computation will never get you there. You can't be half deterministic. Sometimes in the LLM space, they'll talk about, oh, this model's more deterministic. I'm sorry, there's no such thing as more deterministic. You either are deterministic or you ain't deterministic, right? Because the definition of determinism is logical, repeatable, explainable, right? Those are fundamental parts of the definition. So you have to really separate from the hype. Now, Gen AI is good for unpredictable signals and what we call wildcard inferences, right? Because you could always use AI, ML, RL for inferences. So what's the advantage of using Gen AI? Well, because it's not a logical model, because it's not Bayesian, it can actually give you some new kinds of information, but it's at high cost and risk. Same thing with Agentic. Agentic is good for tasks that are hard to systematize deterministically, right? More informal processes. But again, they do that. It's only basic logic, basic memory, basic planning, and quote unquote reasoning at high cost risk. So we need to bridge this gap. If we look at the workarounds, graph RAG, chain of thought, mixture of expert, it's all more tokens, more agents, more models, more money, more GPUs, right? It seems to be a bit of a game, right? Or circular logic, to get better results, you need to spend more money, right? And that's the algorithm for any kind of brute force solution. So with these techniques, you only get marginal improvement in inference accuracy and hallucination reduction, while you're significantly increasing solution complexity, token use, and latency. So these, while Gen AI and Agentic AI are supposed to be magical, you look at all the scaffolding, the flimsy scaffolding that's being thrown up around them, and the cost of that scaffolding, of deploying it and maintaining it. It's not as easy as they had suggested, and it's not as good as they suggest either. But yet Gen AI and Agentic AI have moved the goalposts even in the telco industry. So there was just this article from November 17th on the right side, telcos increasingly turning to Agentic AI for network management, right? And the link's right there. And then of course in the TMF is now, creating these maturity models for autonomous networks, even though the latest reports show that it's mostly just still chatbots for customer service. But clearly you could see the trajectory, right? there is a demand to make these things better and use them. So let's do this together and make it safe, right? So what do we really need to do autonomous networking? Let's start from the objective, right? That's, and then work back. What are the requirements to support that objective? I mean, that's what good design does, right? You look at the use case, you look at the requirements for the use case, and then you sort of detail what you need to do for the scope of work. And really underneath autonomous networking, what you really need to be able to support is real-time, telco-grade, contextual automation. Well, that's a tall order. That's not super easy, right? Having context is expensive. Processing things in real time is expensive. You guys all doing things that are telco grade is expensive. So how do we do this in a modern way to lower those costs, make it easier, and to enable autonomous networking and help the industry realize next level OpEx savings, next level service improvements, next level efficiencies and service acceleration. So how do we get there? I was just at the Network Automation Forum's AutoCon conference in Austin, and it was 700 network engineers. And in listening to all their talks and seeing where the industry's going, and that's a bigger scope than just telco. So it's a lot of enterprise, life sciences, manufacturing. So it's a broad swath of people involved in network engineering. But there is something common with all of you, if you don't mind me saying so. I think everyone that works in network engineering is a bit of a masochist, because network engineering is inherently complex, right? You have a huge problem space. Distributed systems are complex on their own, but actually the network is a superset of distributed system complexity, because you deliver the network itself that supports that distributed system. And you want to deliver the network in a cloud native kind of way, so the whole thing becomes very deeply recursive, right? But there is hope here, right? Because you know what? Actually, network topologies that you guys all live and breathe are graphs, right? A distributed system is a graph, right? It's sets of nodes. A network topology is a graph. It's a set of nodes, and those that have relationships, and that can be modeled, and those nodes and relationships can be modeled as objects. So there's a natural path between network topologies as you already understand them, service topologies as you already understand them, dependency graphs as you already understand them, and graph technology. But how do we get there? Because I know a lot of telcos around the world have attempted to use graphs and have struggled with performance, struggled with modeling their real world complexity, struggled with serving the more advanced use cases. But again, recent article from October, you can see that even words like, I'm not the only one trying to bridge these concepts. People are starting to recognize that topology and this word ontology, and ontology is a form of graph. It's an abstraction of an ontology abstracts common concepts, types, and policies across use cases. It's a model of a domain above the actual use cases and objects of the domain. Because it's a model that's abstracted that pulls out the common concepts, types, and policies, it allows you to reason across use cases. That's the power of an ontology. And it's a deterministic model. It's modeled on relationships. It's not just data and statistics and algorithms. So this article, I should point out, it quotes Ericsson, it quotes Orange, Telstra, and DT. They're all quoted in this article. They all want to go in this direction. They all know this is fundamental to their needs. But the article literally concludes that none of them really know how to do it. So let's actually let's unpack the problem space and talk about how to do this. So if we already understand that a topology is a form of a graph that connects your elements that in the relationships, and they're living, your topology is a living network, right? It's also in space and time. There's actually geography. It's mapped to locations, physical locations, state, telemetry. There's behavior. It has operations. So it's a complex model, whereas a schema just models basic relationships. It's really like a data model. It's something much smaller, and it supports queries and analytics, and it's more use case oriented generally. An ontology is a much more formal model of the complex relationships and constraints between classes and properties, which allows this more expressive semantic reasoning. This is how you get ultimately to the kind of context you want. In other words, you want to be able to look down on the network. You want to be able to look down into that network topology. You want to be able to reason across services, be able to drill down within a service, look at the relationship between elements of a service, understand them both in their local context as a discrete service, but also in their global context as part of a greater network. Well, that means you need an abstraction layer to do that, right? You can't do that bottom up. You need an abstraction layer over the top. Here, in our case, we already have an out-of-the-box, ready-to-use, harmonized standards-based model, and that's obviously just an indication, a simplified. In the demo, you're going to see how rich our model is, but you can see our model already provides an out-of-the-box, ready-to-use model of the entire industry across day 0, day 1, day 2 operations and beyond. From layer 7 to layer down to layer 1. And the point of an ontology being a formal model is it supports it's deterministic. It supports exact matches, right? Facts, right? Not just probabilities, not just approximate matches. So formal semantics provide for deterministic reasoning. And some of you guys know this, but I think a lot of people are relatively new to graph, and they just know maybe the tool that's been thrown in front of them or something that they've heard from some other people. And I think the graph industry doesn't do a lot of this kind of systems level descriptions. It just really focuses on the data, because that's what most graphs just do, is data analytics and recommendations. They don't cross the boundary into ops. And that's the leap for you guys as a community, right? So going beyond KG, or the knowledge graph. So remember, there's graph data, right? A topology has objects, and those objects are graph data. And then an ontology is an abstraction of that environment that has the common concepts, types, and policies. So it brings together the ontology and the data together collectively are a knowledge graph. But going beyond that, it's really the knowledge graph is just a means to the end. What you want is that context. What you want is that reasoning. And context is the buzzword you're hearing everywhere, because you need context for language models, agentic AI, autonomous networking, root cause analysis, intent-based orchestration, digital twins, chatbots, microservices. Everything in your world needs real-time operational context to be optimized. So context is, the KG itself is not context. Leveraging the domain knowledge and the object state telemetry. In other words, processing is how you get context. Reasoning is how you get context. Querying is how you get context. So the knowledge graph is a means to an ends that supports the context that you want. And what is context itself? Context, it can be defined as relevant, out-of-band information. In other words, every interaction, event, or request has in-band information, right? It has your header, it has the body, and you have some in-band information about it. But the context is the information that you could backfill so that you could better understand that event and respond to that event with the broader context. In anytime, I have a conversation, whether it's Graham or Tom at the IWPC, they both understand the telco space. I don't have to tell them every detail, because they have they have knowledge, right? And so I could speak at a high level. They can take my in-band context, and then they can extrapolate and map it to information they already know, and that's how they understand what I'm talking about. Well, you want your systems to be able to do that same thing. You want them to be able to interpret an event, not just leveraging the in-band metadata, but also the out-of-band information. And relevant just doesn't mean current. It could also be temporal history, right? It could be because you might want to do predictive analytics. So relevant out-of-band information divided by permissions, because you need that RBAC and ABAC. You don't want your agent exfiltrating all your data, right? You don't want your agent, just like you wouldn't want any human or system client, getting access to data it can't have. You guys are highly regulated, and you need, of course, you're also, as an industry, the most subject to attacks of any industry in the world. So security is critical. So relevant out-of-band information divided by permissions. So, in a more vernacular, you would just call that the right information, the right time to the right client, right? Now, historically, it's pretty recognized that global context is key to situational awareness, right? But historically, global context has been expensive. All of you as developers and engineers know that you have an I/O budget, right? And so you tend to throttle what you do on an interaction level because of that what you can reasonably do from an I/O and processing perspective. So the question is, how do we lower the cost of context, right? How do we lower that cost so we can get more context in the pipe, so we can optimize those interactions? So when we start thinking about, we start taking this view of what context is, you realize what pipeline, the context itself is a dynamic pipeline over that knowledge graph, right? It's a recursive function making complex ad hoc queries to interpret intent, evaluate conditions, translate policies, and filter data. Right? And I know I'm speaking fast and sharing a lot of information, but you're going to get the deck, and this will be recorded, so you can replay this and share it with your colleagues. And I really want to tell a full story in the time we have today. So hopefully, I am supporting some new ways of thinking about what how to realize agentic AI and autonomous networking. So let's think of it now. Let's take this to its logical extent, and so and talk about context as server and an MCP server, a model context protocol server. And it's not the only type of server. We support there's a wide array of AI servers and gateways and all those things competing right now, but it is the most popular, the MCP model context protocol, and it's a way of serving context to an agent. And so this is just a high-level diagram of things that you've seen before. But what we're showing is at the top you've got LangGraph agents, or agents of really any kind. And the bottom you have language models. And we don't really care if they're large language models or small language models, if it's in the cloud or if it's on-prem, at the edge or at the data center. It's irrelevant. To us, what we're showing you here is that the KG, the combination of the ontology and your catalog and inventory, your repo and CMDB, which hosts your objects, is the intermediary, right, between southbound to your models and language models and northbound to your agents. It's mediating the relationships. It's serving context, both southbound and northbound. And what do we get as a result of that? Well, it's well beyond GraphRag, right? Because we're now really talking about, we're not talking about, GraphRag is essentially a glorified document highlighter for an LLM, right? It's, a lot of expense with a limited return. It's brute forced, you're serving docs. We're talking about serving objects, right? You guys all know the distinction about serving objects versus serving context, right? Deterministic context. So that's what we're really getting here. So southbound, we're able to support optimized interactions with LLMs, low token, low latency, energy efficient. When we work with an LLM, as we benchmarked with our friends at Red Hat, Dell, and Intel, we're sending 3 to 5 tokens at a time. 3, 4, or 5 tokens at a time. In a multi-turn transaction, that might be 15 total tokens, not 35 to 50,000, not 50,000 to 100,000. That's incredibly wasteful brute force, right? And we're using, since we're actually shifting processing to the LLM, which has the domain knowledge, it's an expert system, we can actually ask very pointed questions of the LLM, more targeted questions of the LLM. If you're an expert, you ask less questions. And if you're an expert, you ask better questions because you're making informed guesses. So we can use language models in a much smarter way and deterministically validate the inferences so they can be used safely as managed inputs into controlled processes. So, and northbound to the agents, we're now exposing this knowledge graph as a blackboard, right? Shared memory, shared domain knowledge, shared objects, temporal history, even shared middleware tools with governance through a secure AI gateway to agents. And now you have something that's much more trustworthy, hyper efficient. It's optimizing the use of language models, both from an efficiency perspective, but also an accuracy perspective. It's providing more security in the use of and access to your data. And the power of that is putting that ontology in the middle. So the knowledge graph becomes the center of a domain-oriented AI architecture, as opposed to becoming the LLM being the center of your architecture. We don't think that's a good idea. If this was easy, it would be done already. You know, recently I just had an exchange. Orla Silla, if you don't know, is one of the authors of the original Semantic Web paper, and with Sir Tim Berners-Lee back in 2001. And at that time, they had a vision of what I'm describing today. Oh, agents just seamlessly interoperating over data. But this quote from just this year, and Orla is saying, well, you know what? Actually, Semantic Web can't really do this. And I'm going to tell you, neither can label property graphs. If you use Neo4j Tiger Graph, I'm sorry, they're not going to get you there. So let's describe why. So we're going down deep into the computer science, right? So let's climb the ladder of abstraction, right? So what we want is expressive power. At the bottom is SQL, right? Everybody's got SQL, relational databases with tables and joins, and you get queries and analytics. If we want to step up a little bit farther, we go to a labeled property graph. And now we're talking about, not talking about tables and joins, we're talking about graph relationships. And graph relationships in the context of a KG is really schemas. It's like I said, it's not really an ontology, it's more of a data model, but you can start doing more advanced queries, analytics, and inferences over those relationships. If you want to do real robust reasoning, you need those formal semantics, and you start going into the domain of Semantic Web. But Semantic Web is really complex to use, it's really slow, and it actually has its own limitations. So it's giving you progressively more expressive power, but let's now talk about some of the challenges here. It's not all graphs are created equal. So, you can, if you just do data and you do metadata catalogs, tables, directories, metric trees, right? They use the term semantics, but that is at best light semantics. There's no reasoning there, right? It's just, mapping between common values, right? And I'm going to have to go through this very quickly, but we all know that SQL and foreign keys and joins are expensive when you want to start really looking into relationships. You get a little bit better when you start talking about labeled property graphs, and they have indexes. So they start getting better on, particularly because they're about properties, particularly on complex properties, but they don't actually really support complex compositions. And so they actually slow down on complex compositions. And so you get halfway there and you don't have all the reasoning. Semantic Web is really not good at complexity. It actually is very good at very formalized reasoning. That's why it's good in academia. But when you actually talk about real-time, what we talked about, the definition or requirements for autonomous networking, we talked about real-time, contextual telco-grade automation. There's no governance here. There's no temporal history. There's no complex dimensional and conditional relationships in Semantic Web. There's no abstractions in Semantic Web. It has some limitations, so we need to go farther, right? And again, you'll get the decks and you'll be able to look at that at your own on your own time. So now, how do we get to the next level? So the next level is actually starting with high-level abstractions on your side of the fence, on the computer science and systems engineering side of the fence, not the data science side. And to do that, what we need to do is start using higher-order logic, types, and functions. And that gets us to something called a hypergraph. And instead of building things up just from a data structure, we're now building things up we're essentially creating abstractions that let us map down into data. And so now, instead of just data objects, we have business objects and digital twins. This dimension of hypergraphs supports multidimensional and conditional relationships. It allows us to support complex real-world operations. In our graph, we can support business logic, service definitions, workflows, temporal history, governance in the graph, not just data. Well, that supports not only efficiencies because it all lives in the same graph, it also supports much more powerful reasoning because it lives in the same graph. So that's where EnterpriseWeb lives. So our thesis is that telcos need declarative graph-based abstractions that enable telco-grade that enable engineers and AI to leverage context as a service, to dynamically assure and optimize networks. It needs to be easy, right? We need developer abstractions, not wonky data science tools. You want primitives, building blocks, and services. You want a DSL for DSLs, right? Something that helps you build your operational domain much faster and helps you maintain it. To ease and speed ontology design, right? Because ontology for you is just a means to an ends. The ends for you is automation and operations. So it needs, of course, to be telco-grade, deterministic, context-aware reasoning that is highly performant, scalable, and resilient with strong governance, right? You guys have a lot of requirements. So again, to get to that near real-time telco-grade contextual. So quick plug for EnterpriseWeb. EnterpriseWeb is hi-fi AI, right? I would argue that everything else I described about AI is really lo-fi, blunt instruments, right? EnterpriseWeb is an expert system. We're serving domain knowledge and objects, not just document chunks and tokens, right? That's a big difference. We support deterministic, hallucination-free AI. So in our demo today, it's going to be Snowflake and EnterpriseWeb, and how we unleash the value of Snowflake AI data in the Snowflake AI data cloud. Of course, we can do this on-premise as well, but it's going to show you how we go beyond semantic layers, how you can talk to your data, and we can support very powerful queries, even over SQL. So in this demo, we're going to show you how we deploy into Snowflake and how we complement and extend Snowflake's OSI, semantic views, Cortex analytics with our domain ontologies, and how the domain ontologies provides this unified network view across a multi-vendor, multi-domain, multi-cloud network. And again, remember, it's going to provide the common semantics, the common metadata, common state, and telemetry across services, across use cases, across domains, so that you can reason across them. It doesn't eliminate, we're not burning down brownfields, right? This is an overlay, right? It's going to plug into your NAS. It's going to plug into your domain orchestrators. It's going to plug into even your lower level automation tools. It's not about eliminating what you have. It's talking about enabling what you want to do. And to do that, you need this overlay, and that overlay needs to be efficient, right? So I think everybody would agree that global visibility, end-to-end automation, and virtualized centrally policy control would be good things. So in this demo, my colleague Bill is going to show you how we project a TMF ODA compliant service inventory over Snowflake AI Data Cloud, and we're going to expose it as TMF open APIs to LangGraph agents via the model context protocol through our secure AI gateway. You might be familiar with Snowflake. This happens to be running in AWS. On the left, you have the AI Data Cloud, the warehouse. On the right, you have their LLM called Cortex. In the middle, you have their Snowpark container services, which is usually for lightweight data apps. But since our entire platform is only 50 megabytes, we literally deploy the entire solution as a data app. It's cloud native, deploys as a cluster of pods, 50 megabytes, and HA, 100 megabytes. deploys in minutes. We're literally running as a native app, a native Snowflake app in Snowpark. What we're going to show you is how we can then use our ontology to introspect the warehouse. We're literally going to look into a SQL warehouse. We're going to generate a set of objects. It's going to be a no copy, right? So we're not going to copy the data. So zero copy. What we're going to do is generate metadata objects filled with standards-based metadata and wrapped with standards-based interfaces that allow us to reason over that Snowflake data. We're going to do that in seconds. Then we're going to be able to expose that securely to LangGraph agents. And then we're going to start able to talk about services. We're going to be able to say, what's the health of this service? Can I deploy any services? What's available for me to deploy? And then deploy a service and even manage its health. So I'm moving pretty quickly now. So you're going to literally see day 0, day 1, day 2 in the time that remains. I'm skipping ahead. And I am going to just flash this on the screen here, and you can screenshot it if you want. Again, the deck's going to be available. The demo is going to be available. So you really are just, please just enjoy the demo. I'm going to pass it to my colleague now, and who's going to run through this for you. And of course, we're not going to touch every detail, but we hopefully you will walk away with a lot of good information. And of course, we hope to do some Q&A here. And we're, of course, I'm Dave at EnterpriseWeb.com. My colleague is Bill at EnterpriseWeb.com. We're happy to take questions offline. All right, guys, I'm going to stop sharing and pass it to my colleague. Bill, take it away.
Thanks, Dave. Can you confirm? Can you see my screen?
Yes.
Okay.
Yeah, we got it.
Awesome. All right. Great to be talking to everyone today. So the demo, as David mentioned, I'm going to cover quite a bit about the integration with Snowflake, but I'm going to start with just giving you a glimpse at the ontology that Dave mentioned, which is really key to all of this. As I walk through the demo, I'll be using different elements, different modules, we call them, in the Enterprise Web platform. I'll just tell you what role I'm playing and effectively which module I'm using. In this case, I'm working with what we call our model manager, and it's just really for solution architects to design, curate, and manage domains. So this lets me look at that ontology that David mentioned. So what you're seeing right here is really a glimpse at the breakdown, right? Which is at the top, you see our meta model, which is really if you want, that DSL for DSLs that allows us to model any domain. It has really all of the kinds of core reusable concepts you'd use across domains. So things like business types, organizations, units, people, etc., generic system types, things like communications protocols, and so on. And even a sort of a very rich platform model that includes implementations of a lot of these things, right? If I were to look at them, and I'm not going to spend much time here, but you can see things like artifacts should be, scripts, images, etc. These are the building blocks. This is a really rich model.
I just want to interject for a second. So we're not showing this to you to scare you, because look, I mean, honestly, if you looked at the TMF SID, right, that's a huge monster, right? And it's hardly comprehensible at a glance, right? It's a big old hierarchical model. What we're trying to show you is how rich our model is, how deep it goes, but also it's fully traversable and navigable. You could literally follow links at any level. You can go from a service up to the ontology, from the ontology down to a service. It supports debug, it supports troubleshooting, it supports, this is the definition of transparency, right? You can query it, you can, reason across this. Again, at first glance, this looks like a lot. But again, think of your own local information models, how complex they are. Think about the industry models, how complex they are. We're sharing you an entire model of the entire industry domain that's ready used out of the box. And I just want you to just have that grain, that context for what we're showing you.
So using that set of building blocks, we're able to actually model the telecom domain, right? We have it here as one harmonized model, but you'll notice underneath what we have are a bunch of subdomains really representing the different standards, bodies, and so on that you want to harmonize across, right? So I can look at the telecom ontology from the lens of someone like TM Forum, which I'll do in a moment. But what we have is, again, always transparent, right? We can drill in and actually see what it looks like to standardize across a domain. And as Dave mentioned, it's rich, but the connected nature of this is what really makes it easy to be able to work with, right? So rather than the SID, and I'll show you the TMF right now, if we look at the TM Forum, we'll see elements that we recognize. So we'll see over here on the left, we see the SID as a set of data models that we've sort of onboarded their core elements. You'll see our open APIs over here, which are including the ODA service inventory. And you'll even see links through to things like interfaces and formats.
You might need to zoom in a little bit to show some of the things that you.
Yeah, well, what I'm going to do, I'm going to show you, I'm going to drill right into one of these, which will give you a really good idea of basically how the system is actually connecting this. If I drill in on the ODA service inventories, I can literally walk across the graph to see the richness. And here, as Dave said, I'll just zoom in a little bit more so you can see it easier. But you're looking at the ODA service inventory. You're looking at the links to specific APIs that it includes from the different families in the open APIs. And like you said, you can literally walk across this. So as I'm walking it, I can actually see that this is connected to a whole family of other APIs. I can even see that if I were to go to any of them, they're all connected to interfaces. And eventually what that means is that every interface that we model from the TM forum automatically is connected with a bunch of protocols, including things like the A to A and MCP protocols, the ones that agents want to be able to work with. So what happens is that as you're modeling a API in EnterpriseWeb, you're literally taking the REST the REST package that they provide, a Postman collection from the TM forum. You upload it into EnterpriseWeb. It recognizes and maps it to this ontology, and what you get for free is an MCP interface to it. You get the ability for an agent to introspect anything that we connect to as far as an inventory goes in TM forum terms. So I'm going to now shift gears and actually walk into the implementation of the use case itself. So we're going to start by taking a quick look, I'll just log in here, at what's provided. What's provided actually in Snowflake. So we're taking a service inventory that's relatively flat. It's SQL data, and it represents really what would be a network inventory. You can see here it's a couple of tables. They're pretty simple. If we go into the elements table, we'll have a look. And this was sample data we found. It's elements that are at the level of things like routers, ports, etc., pods. There's nothing here that has services or the other kind of higher level abstractions. It's really a lower level inventory. And then there's some metrics that are connected to it, data points, configuration pieces, etc., that are really tied to these elements. And what we want to be able to do is use EnterpriseWeb to project that ontology on top of this and start really asking questions, automating services over the top of these elements. So we're going to do that by logging into one of the EnterpriseWeb modules, our knowledge plane. And it's really just used for mapping sources effectively, right? So I can go into this module and I can walk through a simple model-driven wizard, basically, right? I can identify that I would like to connect to a network inventory, Snowflake. All I have to do is provide the details for connection, right? So Snowflake endpoint and any credentials I need to actually connect to that. So we've got an access token here. And what's going to happen is the system's going to look at the source that we identified. It's a learning system. So in this case, it's seen things like this before. It's pretty certain that it's a Snowflake warehouse, but you can see it might be coming from other sources. It'll identify what that is. And once I confirm it, the system in that time interrogated what was in Snowflake and started to match it to our ontology. Remember, it's zero copy, as David mentioned, but it's going to be adding metadata on top. It looked at those SQL tables that we saw before, and if I expand this, I can see a lot of details about it. There was that elements table and metrics, but what it realized, without going into a whole lot of detail, is there was value added, the relationships it could impose over the top. It could literally synthesize abstractions for services and functions out of that data, and even a relationships table, and push them back into Snowflake. So we can do a bidirectional, we can basically enrich what's in Snowflake if we give it permissions, which we'll do. It also recognizes there's a potential ODA service inventory that might be relevant here. So we'll go ahead and we'll actually just confirm or allow the system to make this connection. And now it's already mapped, meaning if I start using other modules in our system, something like our network manager, which NetOps personnel would use to look at network service elements, what I'm going to find is right away, I can already see what's mapped, right? It's taken things like those routers and switches and so on, and it's layered over the top services that weren't there before, right? I can drill into any of them and I can see a whole bunch of detail. And in the interest of time, I'll go a little quickly here, but it was able to recognize that there was a Camelio IMS over the top, whatever that is. It will literally tell you or expose it through an MCP interface. So it was able to recognize that from our inventory, take a look and actually put over the top, as David mentioned, you're building metadata for standard-based properties and interfaces. Well, here it actually created an inventory endpoint without anybody writing code for those the two APIs from the TM forum that were related to this ODA inventory. So I could access it straight up TM forum way. I could look at it through an ODA MCP lens, which is how the agent is going to look at it. So for this service, with a click, you can see in half a second or whatever that was, or really a split second, it put together all the context around this service so that an agent could reason about it. A full description, container-based service, and what an IMS is, all the service characteristics and TM forum terms, all the TM forum references, etc., life cycles, component details, basically anything an agent might want to know about the service, and it extends across all those elements. I can even visualize it if I want to. I can actually see that network topology. These are the services that it discovered that we're running. I can slice and dice this however I want. I want to see it as functions and pods, and so on. A lot of nice capabilities from our side by just layering the ontology over the top of that data. And then if we walk on the other side, which is we come back to Snowflake, what we'll see here is we talked about bidirectional, right? We actually enhanced the Snowflake tables. Right? You can see that there were a few new ones that came floating in here. There's actually a service table now that was generated based on this data, and we're pushing back the details that we discovered. So you get this bidirectional interface that's already set up now through EnterpriseWeb. So
obviously, we'd have to have permissions from the Snowflake warehouse to be able to push that back, and we're not changing the underlying data. We're just actually enhancing the structures, and we're essentially pushing back. A SQL database can't really represent graph relationships truly, but we are putting more context and push into that SQL warehouse. So that's would be a very attractive feature. Doesn't have to be used. We can just have the metadata objects on our side, but it's a capability that we can actually make this bilateral.
I'm going to show you how we can really leverage this kind of capability in an agent context. So I created a land graph agent using our system, right? And it's using, as David mentioned, it's using the Cortex LLM for its, that side of things. It's using a couple of services that we exposed, that MCP endpoint that you just saw for querying the inventory. That's all hooked to this agent, which is called a worker orchestrator, which is really, it's more than just a chatbot. It can actually perform functions and with safety of the EnterpriseWeb platform around it. So I'm going to log in. The first thing it makes you do is enter your token so that you're secure. So everything you do is through your lens of security. It's a service manager agent. I can actually ask questions like, what can you do? And I can answer questions about network services I'm aware of, their state, and I can also order new services and respond to events. So this is a highly capable agent already, right? What services are there? And this is what it basically discovered. You can see it's reflecting what's in the background. I can ask more questions if I want, but in the interest of time, I'm going to order a new service, right? So order a new service. It'll go in, it'll see what's available. There's only one thing in our catalog we can order. So we'll go ahead and actually just follow the prompt. Yes, that's what we'll deploy. And we'll pick the top cluster, right? So just like that, it's already used the EnterpriseWeb platform to start doing a deployment, right? I can ask more questions about it right from the agent if I want, right? Which is always a nice feature. Let's just copy there. Nothing here. So let's move more about. And this is going in, it takes literally everything. A full nice description of what this is, all its status, what it's available, etc. So good, we have a service. If we went into EnterpriseWeb now, which we'll just do, we looked at our network manager before, now we're concerned with services, so we'll go into our service module. And we can see our catalog that had things we could order, that was the service. We're concerned with the inventory. So we get a nice picture of the inventory. You can see the new service that we have, not the ones that were discovered. We've got a dashboard that it actually stood up. So there's observability that was configured around this. So I can actually get a dashboard and Grafana of how this service is performing. And there's a nice audit trail here in EnterpriseWeb of everything that was done in relation to that MCP order, right? So at a very fine level. It supports all the trace you might want. Now, what we want to do, though, is I want to actually show you how the system would respond to events, right? Meaning, if I just pop into the dashboard here, I'm going to overwhelm the service on purpose, right? So I'm going to simulate a whole bunch of traffic here so you can see how our agent reacts in a day 2 scenario, right? So I'm going to start a simulation here on the right, right? And basically, you can see a couple of things. It's instant pretty much, but our dashboards are now reflecting that this thing's overwhelmed. You can see it reflected in the latency and so on. Basically, there's a whole ton of traffic being pushed at this. And what happened is our agent actually automatically detected it, right? There was poor performance. It's now interacting with our system to do some RCA, right? So performance was degraded, and in this case, it's just suggesting that if we turn on to agent policies, we'll get a fix. That's easy for demo, but it will start to walk you down a really complex root cause analysis to tell you what the problems might be and suggest fixes. If you authorize the agent to do that, which will do it, you'll see it's almost immediate, right? We've already got something that's starting to make changes to our network. All of our levels drop. If we go back into EnterpriseWeb, we can see exactly what happened, right? We can see there's a new event, which was to basically have our system activate that monitoring, right? If we go in, we'll actually see that there's an event trace here that's going to start to fill up with the different operations. You can see here's the first one that came floating in that really impacted our operations, but it's now going to be optimized as it goes forward, right? So this is going to continue to flood in with events. And if you were to look at the details in them, you'd see at a very low level that when we actually worked with the LLM to figure out this continuous optimization, though, in this case, the 3 tokens, right? 2 input, 1 output, to help us figure out what was a pretty complex change to the low level configurations of a particular component. If you pop back into Snowflake, which is where I will end, then what you'll see is that we also have another if you want, another place where we've enriched the Snowflake experience on the other side. Not only are we doing things like pushing back, in this case, updating the structures to reflect the new abstractions, but if we go into things like, where is it here? Their Cortex analyst, so their AI side, you'll see that we actually generated what they call a semantic view. There's literally a capability now that works with their AI to analyze agents. So it built what is going to be a pretty complex framework of SQL behind the scenes, but it reflects now what the agent's actually doing. So I can ask questions. This is where it gets really exciting, is what's the average impact of the per operation, right? So I can go in and ask an LLM how that agent is performing. It will go in and figure out everything that's needed through the interface. It'll interpret our question, generate SQL, and eventually even give me a solution up here, in SQL terms. But this, again, starts to automate that other side for someone like a Snowflake customer who typically takes a long time to manually configure and create something like this. We've really done it for them almost instantly without any work. So that was my speed run through the demo. I hope that was helpful, and look forward to any questions.
Good job, Bill. Graham, we actually left a couple minutes.
Yeah, thanks, Dave. I've just put one question into the chat box, actually, which came in from Deutsche Telekom. I think you may have seen it. He was interested in closed loop integration, learning from historical data, automated monitoring, mixed.
I'll just read it out. I don't know. So it's from DT, closed loop integration, learning from historical data, automated monitoring. So actually a lot of it combined with context from knowledge base. So this was I think a question submitted in advance of the webinar, right?
Yeah.
Okay. So a lot of this we actually presented, and we had like 20, 30 really good questions submitted prior to. So there's a lot of interest in this demo, and we got a lot of questions submitted, good, thoughtful questions. So it does indicate to me that people in telco are trying to think about graph and are struggling and are looking to deal with these problems. So the person is actually saying, okay, well, we need closed loop. It's not just the knowledge graph. We need closed loop. We need historical data because we need to do predictive analytics. We talked about that. The graph has that. You need to be able to do recommendations. Actually, Bill showed you not only the NLP conversation with the LangGraph agent on our side, he also went to the other side through Snowflake directly and showed you how you could get analysis on the Snowflake side. So we're working with LLMs, but you putting the ontology at the center, right? Putting that deterministic knowledge foundation at the core improves everything, right? Improves the accuracy, it improves how concise the summaries are going to be. You're working with objects, not docs, right? And I think you can all understand, docs are blunt instruments. Like, it's like if your child walked by and asked you, Daddy, why, or Mommy, why is the sky blue? And you threw an encyclopedia at them. That's a blunt instrument, right? Go find it. Hope you find the context inside that encyclopedia, right? As opposed to just telling them because you have the knowledge, right? And that's what we're really doing. If you put expertise at the core, determinism at the core, it actually strengthens everything. And hopefully that resonated. But yeah, we're supporting, actually one thing we didn't really get to in this demo is, since the whole our platform's entire system is immutable, all data everything's being logged, everything's being traced. We point AI back into the logs, and now we have a learning system. In other words, the platform itself gets smarter with activity. The more you use the system, the more objects you have, the more complex use cases you have, the more transactions you have, the system activity is all being logged and growing, and then we're putting AI over the top to look back in that activity and then optimize the performance of the system itself and next actions. So this becomes recursive, right? This becomes this self-fulfilling thing where you just get better from use. That is a flywheel, right? They call that a positive self-reinforcing loop, where you just grow. So you have an adaptive and learning system. These are the kind of things that people want.
Okay, Dave, I'm not sure if you covered this during the presentation. The question was, can operators implement these graphs on their own, or they required third parties to implement them? Does the use of graphs have any implication on telecom operators, OSS, BSS vendors?
Oh, that's a great question. Actually, I was literally talking to Sridhar Rao. He's the CTO for the telecom for Snowflake, and he was saying how important it is for telcos to be able to do this themselves. And that's actually... Right. So I didn't touch on this directly, but indirectly. If you remember, a couple times I said the importance of having developer abstractions with primitives, building blocks, and services. Because if you build an ontology with Semantic Web or try to do it, you can't really build it. You can't. LPG, no matter what those vendors say, doesn't really support ontology. It's just a lie. Semantic Web sort of does, but there's no primitives. There's no way to do it easily. There's no governance. There's no native security. There's no nothing. You do it manually. And of course, that's super error prone. EnterpriseWeb, because we have an abstraction layer, it's a DSL for DSL, it drives you to creating well-formed domains and well-formed objects. It sort of speeds and eases the design. Now, we give the telcos that harmonized standards-based ontology out of the box. It's ready to use. Use it or don't use it. Use it to your heart's content. Working with a tier one telecom, they gave us a JSON file representing their internal information model. We imported that JSON file, pointed the ontology at that information model, extracted entities, and created objects inside our graph, so that their operational concepts, types, and policies lived side by side in that same ontology. So yes, we make it, we greatly enhance the ability for telcos to do to design and maintain their own ontologies. Again, we maintain the telco ontology, so the standards-based one, and then we make it easy. And of course, we can support the telcos doing their own. But actually, the whole thing is 100% declarative, no code. You use the dev abstractions we give you to maintain your own ontology, and you can, because it's governed by an abstraction, you can start small. You can start with a single use case for a single domain for a single team. But since you have a platform over the top, you can slowly expand it, right? And that platform is not competing with your NAS. It's not competing with your domain orchestrators. It's not competing with your AI. It ends up just providing services, to the developer team to help enable these things that they want to do. So I think that's a great question, maybe to even end on. Actually, of course, I'll take another one. But importance of
no worries, Dave. No worries. So yeah, I was going to say, just give us a few closing statements, because we are over time now. So, and as you know, there were a few questions that had come in. So if you wouldn't mind, I'm going to ask you to just follow up with those people individually and cover those questions, and we'll see where that goes to from here. But Dave and Bill, any last comments before we close?
Hey, this is super easy to do. We're doing it with Snowflake. You can contact Sridhar Rao. He's CTO Telcom at Snowflake, and then they can stand up a sandbox for you near immediately. They'd be happy to do that. Well, of course, we can do this for you as well. We can do this on-prem. We can do a POC. So don't have to be scared of this. It deploys in minutes. We can prove a small use case with indicative complexity, and then we can grow that use case and scale. You could scale it over time. So all about this whole presentation is about making these things practical for your net ops, right? Trying to take these concepts. Everybody's throwing AI at you, language models, agents, and at the end of the day, it's not just playing with these. It's actually, how do you do them in a telco grade? You guys are rigorous by trade. You are rigorous folks, and we are trying to help and lower the cognitive load, reduce developer toil, and make your jobs, make you guys more successful in your jobs. Help your organizations realize their initiatives. So David at EnterpriseWeb.com, Bill at EnterpriseWeb.com, Tom, Graham, Debbie, Laurie, everyone at IWPC, we super thank you for giving us this forum for the presentation today. And everyone on the call will share, the IWPC will share the deck, and they will share the link to the replay. So thanks for your time and interest.
Thank you.
Thanks, Dave. Yeah, and as you say, I mean, there will be people coming to look at this in the research library because, as we know, people tend not to be able to always make these live. So thanks a lot, Dave. Thanks, Bill. Really appreciate you coming on, and look forward to catching up with you again soon.
Our pleasure. Bye-bye now.